yes, we are talking about biblical majuscule, and then a quick introduction. Biblical majuscule is a writing style that is a fixed set of general letter forms, which can vary slightly from scribe to scribe. And it was used as a style to write every kind of literary texts from the 2nd century CE onwards. And something special about the early stage of biblical majuscule is that the scribes wrote the letters in an extremely similar way. And we can call interscribal variation or intrascribal variation was that particularly smaller than in other styles. Not the within writer variation, but like Milan is called, but the interscribal variation, the variation between two writers. This would be the set of the general or standard forms of the letters in biblical majuscule, according to Orsini's and Clarisse's article from 2012. And then our challenge was here, can we distinguish hands? Can we establish something about scribes? Can we say with some certainty these two papyri were written by the same hand or these two papyri weren't? Now, Isabelle talked yesterday about the dataset of Homer papyri, which was created during her project These Scribes here in Basel. 150 papyri were annotated at the character level by Olga Serbaeva as part of that project and can be seen in Palex after being done in Reed, also with Stephen White here present. And then we have this platform Palex where we can compare the cliplets of every papyrus in the dataset. Now our smaller data set of biblical majuscule are these 8 elements, these 8 TM numbers, and from all 150 Homer papyri, we took these ones because they were described by their editors as having been written in the biblical majuscule style. We also exceptionally added in the one below, the 5910170, because it was put as a comparison term by the editor of the 60764, Nicolaus Gonis, this outsider. But in biblical majuscule, it contains Apollonius Rhodius's Argonautica and not Homer Iliad. And then our starting impulse was the assumption, also by Nicolaus Gonis in this edition of the 60764, there is a chance, I think, he wrote, that we are dealing with three roles copied by the same scribe. And by that, he meant these 3 TM numbers. Now, were we going to be able to prove or to disprove this hypothesis? And we are comparing two approaches, two complementary approaches, that of the paleography and that of the AI. I will be explaining the paleographical approach. So my methodology was comparing the papyri and to answer the aforementioned questions, took the following path. First of all, the assumption that we only have one scribe per fragment. That would be a nice discussion with Mladen afterwards. Second, we looked for 9 relevant letters, this set of letters. Because I thought they differed the most from one papyrus to another. And then we compared pairs of papyri, every papyrus pair by pair and letter by letter, looking for relevant differences. And what would be a relevant difference? I followed this principle that 2 papyri are not considered different in relation to one letter if the variation between them is smaller than the intrascribal variation in one of them. This within writer variation that Milan talked about. Unfortunately, not every comparison has as a result the values similar or different, due to the fact that the papyri fragments we are dealing with are often quite small. And then I figured out a 3-term scale and I gave them 3 colors. try to gap the bridge between these little fragments. So in red, the letters that are clearly different, that we have enough evidence to say they are different. In black, the letters we have enough evidence to say they are clearly similar between two papyri. And in gray, the letters we have not the evidence to say they are clearly different. They could be similar and written by the same scribe. So in a comparison of two papyri, we would have this kind of table. Now I skipped examples of the decision making in each case, but we can go back if some question are arising in the discussion. So now we got this kind of table only from the paleographical human eye perspective. And then we gave for the visibility this kind of similarity values or similarity scores between the papyri and try to throw conclusions. So can we be sure of anything talking about this papyri? The first conclusion is that this one is the most different one from every other papyrus. It scores -2 the best. So it could be, if you look at the cliplets, the letter forms, you see that these are very irregular hands. So maybe it wasn't skilled scribed, like also Milan said, or maybe we could also try to describe this style as not exactly a typical biblical majuscule one, or at the border between biblical majuscule and other styles, mixed style or something like that. Another conclusion, and going back to Goni's assumption, is that the three manuscripts he compared or he linked indeed score very high, considering the general situation. We only have 0 or plus scores, and the almost the best scores in the whole table. We would just have one other +3 here. And then another conclusion we weren't looking for is that the 3 fragments of the TM number 6764, the 3 images, have striking differences from one another. And we compared the fragments separately, and also with the computer, and we found enough differences to think they actually maybe weren't written by the same scribe, and they were connected by the editors because they were in the same biblical majuscule writing, or they were acquired at the same moment. And now I will let Giuseppe speak about IA.
Okay, thank you, Pedro. I'm here now. I'm going to explain the other approach we followed, that it's totally based on artificial intelligence. But you can ask why we have to use artificial intelligence to try to solve this problem, try to find some measure of similarities between images. And the answer that may be found in these 3 points. There's a problem when a human has to define similarity between images. That is because for us, it's really difficult to find a metric between images. It's not really easy to define the way we want to say these 2 images are similar or these 2 images are dissimilar, because we cannot measure our feelings, we cannot measure our approach. And if we try to do it, we need to put a lot of effort and we need a lot of time to complete this process. And that may be a problem if we have to handle a lot of images and a lot of TMs, a lot of letters, so we need all of that. With machines, we can just skip this process, because in a few minutes, we may let the machine to provide us numbers, to provide us a measure of similarities. And that is what neural network can do for us. I don't want to say that they can give us answer or they can jump to any conclusion, because they can't. But they can provide us a space in which we can measure similarity between images. That is an approach that is followed in several fielding, and we can just take this approach and use it to measure similarity, but specializing our architecture to work with images of Greek letters. To do that, we just take this architecture and it basically take two images, work on these two images, try to compute the similarity by itself. And it provides us just a number that it's between 0 and 1. 0 means the two images are totally different. 1 means the two images are exactly the same. We specialized this architecture to work with letters, Greek letters, by training the architecture only on images of letters. To do that, we just take this data set that is used in this ICDAR 2023 competition. It's just a collection of letters written in Greek, but it's important to say that in this training, not all the letters are biblical majuscule letters. So they are just letters of ancient Greek written on Papyri. And we took only images of BT1 class. It means that, as Isabelle told us yesterday, these are only images that are complete, that display complete letters. There is no part of the letter that it's missing. That is because probably for a human it may be easy to recognize that kind of letters, because we used to apply some sort of reconstruction in the pattern of the image. But if something is missing in the image, probably the machine, they may have some problem in recognizing. So we are sure, using only BT1, that if we are showing an alpha to the machine, the image, it's an image of an alpha. At the end of the training stage, the network is able to provide us this number that measures the similarity. And at this point, we took another data set composed only of biblical majuscule letter and evaluate all the distances, all the differences on these data sets. So what we got is just between all the couple of images into the data set, the network provides us a number that measures the similarity between two images. Now, if the data set is a little bit big, it may be not really easy to understand what the machine is telling us. So we have to find a way to visualize our results, to try to make the interaction between human and machine as easy as possible. We can just use graph, that it's one of the easiest way to proceed. And we have decided to show the result of the machine using this kind of graph. The idea of this graph, it's easy. We can have a representation of our validation set. So each dot in the image represents an image of a letter in our datasets. The dots may be connected, and to each connection is associated the number that the network provides us to measure the similarity between the two images. In the example, it means that these two dots are linked with a similarity score of 0.999. It means that for the machine, that two examples are really similar. And it's interesting to use this representation because we can see how the network measures the similarity between all the images, just letting vary the threshold of similarity. So we see the similarity score is changing, and it's interesting to see that the first dots that links together belongs to the same document. That it makes sense because probably they are written to the same one. But it's also interesting to say that there are connections with a high level of similarity that appears between TMs that are different, like the pink one and the green one. There are a lot of connections. And there are some other one that does not link very well with the others. And there are some images that behave like a bridge between these different clusters. And these are more or less the distance path on the evaluation data set. We take these 3 letters because in our evaluation data set, we have only these alpha, epsilon, and mu letters. But they are more or less enough to say that if we look to alpha and epsilon, we can see that there are some behaviors that are in common, because the 2 graphs look a little bit similar. We have, for example, the blue dots on the left that stay every time alone. We have this connection between the green one and the pink one, and the light blue that it's more or less on the bottom. But at this level, the graphs just try to measure the similarity between all images. Our initial goal was to measure similarity between writers, between TMs. So we can just skip to another sort of representation that it's a little bit clear. And it's again a distance graph, but it's based on the TMs. So all the dots now are not single images, but are set of images belonging to the same TM. And the connection between all the dots measure the similarity between TMs. Now, what's important to say is that to obtain a graph like that, it's easy. When we have the model, when we have trained all our network, we can just take all the elements that we want to study, put everything into the machine, and in a couple of minutes, we can have a representation like that. We can see this representation and we can just try to understand easily what is happening. The point is, I'm not an expert, and I, as a data scientist, can provide you some result like that. And I can, of course, say something about this representation because it's clear that there is something that is happening, like the blue dot that is alone on the top. And if you see the number that is 61051, it's the same TM that Pedro in its study leave alone also itself. So it means that probably there is something about that TMs that it's different from the others. But it needs a lot of effort to jump to this conclusion. But what if we can start from this representation to start its analysis? Probably it can save a lot of time and a lot of effort. I can do other kind of observation. First of all, you can see that they are all connected. And it means that there are a similarity between all the images. The computer doesn't know that they are all biblical majuscule, but we know. So that may have some sense that can enforce the results that it gives us. We can, of course, say other things about the connection to see what is happening into this set. But I say I'm not really an expert, and that's because I want to share this representation with Pedro, because Pedro is the expert. Pedro, the eye of Pedro can see things on this graph that I cannot. So that's because for the conclusion, it's probably better if Pedro can take the stage again and describe us what I can provide to you.
Mm-hmm. Yeah, very nice. So yeah, the last comments here, and also showing that the data we have, the results we have, are connecting and complementing each other. As Giuseppe said, this 61051 is isolated. Then the Goni's assumption again was to link this 68242, the 6764, and the and the 6934. They are similar, but they are not the only ones that are similar to each other. So we would have as a bridge this other one that also Gon is linked. As we may remember, this is the outsider, not Homer Iliad. So he had all the right to link them, but we have no proof so far, nor from the computer, nor from the human eye, that they were really written by the same scribe. These 3, and also the what I talked about, the 6764 is split into 2. So this is another hint in the direction that we may consider these TM numbers to have been written by at least two different scribes. So yes, to end this presentation, the conclusion or the results of paleography and AI are similar. The Gonny's assumption, the suspicion of the 764 and the isolation of this one. And then the problem of threshold is a shared problem between AI and the human eye. This threshold concerning the intra-scriber variation, the within-writer variation, it had an interesting resonance in the computational approach, because the neural network at some point or at some threshold, as we saw in this clip, started connecting letters from one papyrus with letters from another papyrus before connecting all the letters of the first one with each other. So this would be a nice hint in the direction that two papyri were written by the same scribe. And yeah, the advantages of the computational paleographical analysis do not exclude the human eye, of course, as an indispensable tool. Rather, a promising collaboration between both approaches is what awaits us in the future, most probably. So, thank you for your attention. Or is it? Yeah. Thanks a lot for your attention, and that's all. Thanks, Giuseppe.